Okay, so before I start, let me briefly explain how we are going to run this course. There's a video in my so first of all, if you are first time and um, raise your hand if you're not still registered. If you raise your hand if you're not registered. Raise your hand if you're not registered. 1, 2, 3, 4, 4 person. Did you register? No? Raise your hand. Raise your hand if you're not registered. 1, 2, 3, 4, 5. Okay. So this is our class page. It's a Notion page. What you need throughout the semester will be uploaded in this page. So if you're registered, you can go to this site with through LMS, because I put the link on LMS. But if you didn't register, you have to use this QR code to access this page. Okay, did you got the QR? Did you get this? And so I'm going to upload the group every class, and this is our group today. This is section 3 and this is section 5. You have to know your section correctly, because I'm teaching 2 sections and I'm going to use the same page for 2 sections. So there are hundreds of persons. Oh, by the way, I heard that there are 2 persons in each sections has a same name. So I know that there's 2 person in our section who has the same name. Can anyone find your name in this section 5? Let me know if you can find your name. That's a different person, but I heard that there is a person in section 5 whose name is same as one of the person in section 3. So can you find any of these names same as yours? No? No? I think it was a girl's name. Okay. Anyway, yeah, so memorize your section number and meet me after class if you're not registered. If you're planning to register this course, okay? Okay, so that's pretty much it. You can see the first video that I uploaded in this lecture video site. One thing that you have to remember is in the first day I mentioned that you have to write something in order to check your class activity, and that didn't work well. So I will not ask you to write anything in the class except for something that we have to do for the programming. So don't worry about the part that you have to do something on the in-class activity part. Okay, so what we're going to do today is the project. So first project. So one more thing is that we're going to do 9 projects. We're going to go through all of these 9, but what you have to do is once we fix our group, you have to pick one project for each group. So we're going to make a group for the first half of the semester, and you'll do 1 project among 9 projects. And then then the second half of the semester, you will pick another group and another project, and you will do 1 more project. So what we're going to do throughout the semester is I'm going to give you the basic mathematical theory and basic code that will demonstrate what the project is, and then you're going to do something more on top of that. So I'm going to give you some additional tasks that you can do based on what I explained. You can see for today's lecture what additional tasks look like. And then you can do one or two additional tasks or all of them. Or you can do something more that I didn't listed for your project assignment. And other than that, a project, I mean, you have to present your project at the midterm week and final week. And also on top of that, you have to write your report based on what you did on the project. The report is either individual or a group. You can choose whatever you want, but I don't want you to write a long report. It's just a short report so that I can check that everyone knows what they're doing and everyone participated. Okay, so let's move on to CAPTCHA. So basically, our group, we're gonna have lots of discussion. We didn't have much discussion last time, so we're gonna have a lot. Right, so I'll briefly explain what this is about, and then we're gonna talk about some of the topics. So first of all, we're gonna talk about the color system. The most common color system you can use is the RGB system. It's basically stands for red, green, and blue. And you can make a color and you can plot a color with a dot figure with this code. So how do you assign the color is by assigning the strengths of each color component. So for example, if you have, so Python uses 0 to 1 strength range for each color. For example, if you set your red, blue, and green and blue to be this much strength, then if you mix all, then you get some purplish color here. So basically what we're going to do is making a CAPTCHA. So I'm giving you the basic, the figure of the CAPTCHA that we're going to make. So this is one of the CAPTCHA. So you can see that these numbers have certain, there are certain features you can see from this picture. They're all number, but they're not, well written. It's because that's what the CAPTCHA is meant for. It meant for human can read, but computer cannot read. So computer could try to read, but the purpose is to make an error for a computer. So in order to do that, first we need to deal with the image. How do you read off the image and then manipulate image files? So for example, if you want to read the image, you can use imread here. Yeah. So there is a pyplot package, the function called imread, and you can read from the file the image information. And you can see that image information, there are lots of types of image, but we're using a PNG image. So this, not only the PNG, but other formats, basically stores the information of the colors. So not just the color, because there are lots of colors in one image, the color associated to each pixel. So you probably know that your monitor size, like your monitor size is FDA, no one has FHD, but something like 2000 pixel by 900 pixel. That means you have that much color dots there. So image is basically in which pixel, which color are shown in the monitor. So they store the information about the color with the pixel coordinate. So here is the picture of 18 by 18 pixel. So it's a very small image if you want to see the original picture. But I'm using this picture so that we understand how we deal with the image. So basically you have the horizontal index and vertical index for the pixel image. So horizontal index increases from left to right, and the vertical index increases from top to bottom. Okay. So if you want to look at the color at the 0, 0 pixel, it's white. So if you want to see the color at, let's say here, 5, 1, then something like pink. Okay. So we want to do something on the image. We don't want to print the image as it is, because overall, at the end, we want to distort the image of a letter or digit, the number. So we need to convert the image information into some sort of a coordinate information. So if you try to use the pixel coordinate as a xy coordinate, what happens is you get this kind of picture. So which means that if you remember how the pixel coordinates are defined, the horizontal pixel coordinate could represent the x coordinate because it increases from left to right. But however, if you want to use the vertical index of the pixel as a y coordinate, it's inverted, right? In the y coordinate, we normally use the upper part as a higher coordinate and lower part as a lower coordinate. But here, you have higher pixel coordinate, vertical pixel coordinate in the bottom and lower and on the top. So if you just use the pixel coordinate as your xy coordinate, you get this inverted image. So you have to do something on here. We'll go through this Python code and how to do this after I give all this information. And also, okay, so let's say we put our image in the upright position. What we want to do is rotate a little bit, because that's one way you can distort image. So rotation is given by matrix multiplication. So for example, if you want to rotate your point x, y with theta degree counterclockwise, what you can get, how you can do is multiplying this 2 by 2 matrix to column matrix. So I'm going to draw a picture here. So you can relate OP prime is the x prime, y prime 2 by 1 matrix, and OP is the xy matrix here. So here's the picture. Here's our P, x, y. Here's our P prime, x prime, y prime. And let's see, this is our position vector. We covered this last time. And we want to rotate this counterclockwise by theta degree. It's a radian, actually. Then, assuming that we know the coordinate of x and y, we want to find the coordinate of x prime and y prime. It's given by this matrix form. So the matrix multiplication, let's recall how we did it, is done by this way. So if you remember in a Korean, the matrix is called 행렬, right? So if you multiply 2 행렬, then you simply take this way, 행렬, 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 like this one. So you take the row in the first matrix and column in the second matrix. So you take the first row of the first matrix, cosine theta times x, and minus second entry, sine theta times y. And the second row and then first column, sine theta x plus cosine theta y. So basically it says that x prime, y prime, the point that after you rotate, are given by the combination of theta and x, the formula of x theta and xy. So this picture is after you rotate 45 degrees of your original picture here. Now, so you have to think a little bit carefully here. You can see, if I enlarge this picture, it's not really the rotation, right? Look at this picture again. So in the original picture, I had this picture, like all the pixel dots are represented by the square. And what I did for the rotation is that I actually didn't rotate it the square. Square is square, right? So I only rotated the pixel coordinate, okay? So I didn't rotate the shape, okay? So I'm just drawing the upright square on each rotated position, okay? So this is not really how you rotate an image, because you see there are lots of dots, lots of empty holes in between these squares, and well, the holes are, fit together with other pixel squares, but it's only because I rotated 45 degree. If I rotate it in different angle, then this hole or this pixel square could overlap each other, and then it will look ugly, right? And also, it's not a actual the pixel image, right? So I only doing this because I'm using in the XY coordinate. So if I want to draw it in a pixel image, I have to do something else, because each points, the square are not in a integer index. So we can think about this after we go through all of this. So let's talk about discuss about the CAPTCHA. So after all, this is about the project. So let's think about, there are more than what I listed here to make a CAPTCHA. But first thing that we can characterize about the CAPTCHA is that it consists of random letters. So here you can throw in some letters, but I just use the numbers. So first of all, it consists of a string of letters or numbers, and also numbers are randomly generated. That's the essence of CAPTCHA. If it's always the same, then why bother making a CAPTCHA? So you need a number, certain length of number, randomly generated. That's the one characteristic of CAPTCHA. And the second characteristic is that you should somehow distort the image of numbers so that human can recognize, but computer can't. And the third and fourth are a little bit overlap each other. So what happens is, if you lay out your number separately so that you can easily read off the numbers, then computer can also read that number easily. So you need to make computer hard to read the numbers. So one way you can do this is by overlapping. But if you used all black color for each letters and overlap each other, human cannot either read the numbers, right? So somehow human can, distinguish the color easily and then see how the numbers are distinct. So you need to use the different colors and overlap each other. And also, if you use the number, without opacity, then somehow you can, I think that might be a good way you can make a CAPTCHA. But also, if it's too overlap each other and then human cannot recognize what the number in betweens are, it's hard to read. So you need some opacity on the color of each letters. So there are some other features that you can throw in, but basically these are the features. Okay, so how do you distort the image? So I'm skipping the code. You can work with your code after the class. So what we're going through, we're not going through the code the same way I put it in this slide. So we're gonna do step by step. The entire code is in the slide. You can, if you want to, you can just copy paste and then see how it works on your computer. So how do you distort the image? So think about this in a theoretical way. So first of all, you need some, stretching and dilating and rotation. So stretching and dilating. So how do you stretch? So you can stretch horizontally or vertically. So this can be done by also matrix multiplication. So for example, if you have lambda 1 diagonal matrix whose diagonal entries are lambda 1 and lambda 2, well, you can imagine that this is, like, say, for example, 2, 0, 0, 1. So I'm going to multiply this diagonal matrix to 2 by 1 matrix representing a point or position vector. What happens is I only dilate the x-coordinate, so I get 2xy, right? So what is this about? So I had xy here, but after stretching, sorry, I should put here, p is xy. After stretching, I get this point, p prime, which is 2x comma y, right? So I'm dilating in a horizontal direction, right? So I'm making it a little bit fatter. And if you use lambda 2 different value than 1, then you get stretching to the vertical direction. So that way you can stretch it. So I'm just stretching only one point. What happens if I put lots of points representing each point representing each pixel? And then I combine all this dilated point into one big picture, then I get this picture. So you can imagine that each point, like pixel point on this image file representing 8 figure is dilated so that, well, this point will move on to this point and so on. So overall, at the end, you get this dilated picture. So what happens after you dilate? You rotate. So rotate it always, if you multiply this matrix, it's always rotation around the origin. So it's important that you put your picture center at the origin. So then you get the nice rotation. So you don't want to rotate too much, because if it's upside down, okay, of course a human can read, but some characters like letters have it's hard to read if you just rotate too much. So you need to specify the range of rotation. So, and also rotation, it should be random. So you need to specify the range of random numbers so that you pick that number as the rotation angle. Okay, so the first one was another example. This one is also another example of the CAPTCHA you can create. So you can see that this 7824045 have all different numbers. You can recognize them by different colors, and there are bigger ones and smaller ones, and sometimes it's rotated left or sometimes it's rotated right. So everyone can read this, right? I'm not sure whether if you put this image into AI, whether AI can read. I'm pretty sure AI these days can read this pretty easily. I didn't test it out. I think I should test it out after this class. But anyway, yeah, so this is our basic project. So let's see. These are all the codes I'm going to go through. So here's another additional task. Our basic project, the objective of the project is to make this CAPTCHA image using Python code. But you can make you can do some additional task if you decided to do this as your project. One thing is that you can add letters to CAPTCHA. That's a very easy part. And also, you can throw in some non-letter thing here. So for example, you can throw in some symbols and ask if what the symbols are in the CAPTCHA image. And also now, normally how you use CAPTCHA is that you have a page that's showing you the CAPTCHA and then ask you to enter the exact letter that you can see from the CAPTCHA, right? So you can make a program using Python code that's showing the CAPTCHA you made with your code, and then there is a box or input prompt, whatever, to type in the exact letter of the CAPTCHA and then whether the input text or letters are correct or not, so that the user can know whether they put the correct CAPTCHA image, CAPTCHA letter. And also maybe you can do something more. Just I think of the additional task. As I mentioned that whether current AI can recognize your text CAPTCHA image, how about you can do some additional task to make a CAPTCHA really complicated so that human might understand, might recognize, but like current AI, ChatGPT, is hard to recognize. So you cannot make a CAPTCHA like 100% um, fail, like every AI machine fails 100% of the time, but sometimes it's something that sometimes AI could not recognize that CAPTCHA. So maybe you can test out your CAPTCHA image into the AI system, and then how good is your CAPTCHA algorithm is, so that your additional task might be, okay, I want to make a CAPTCHA algorithm such that the failure rate for AI system is over this much, something like this. All right, so basically that's our project. So rest of the time we're going to actually do the project using the Python. So before I begin, is there any questions? No? All right. So anyone, there's only one person. So what we are doing for the Python is you have to go to Replit. And also, if anyone not in the last week's class, I'll tell you again, go to replit.com, R-E-P-L-I-T, and create account. I just logged in automatically, so you have to log in first, make an account first, and then log in. And once you've done that, create a REPL. Your name of the REPL can be anything, but I advise you to write in this format, digist-mcal-2024- your student ID and dash your name. So I'm gonna go to mine. When you create a REPL, there are some options you have to choose. Click Python template and make the title. What was it? Yeah, digist mcal 2024, your student ID, whatever. I'm pretty sure everyone else done that, so you don't have to follow again. And your name in Korean, if you can. So, and then create. All right, so maybe I have to go through fast. So maybe if you struggle, then the person next to you can help. So this is our okay. So I have to make whole folder here. So it's okay. So we decided to make a folder each day. So well, what's the date today? Is it fourth? Fourth, yes. Okay, so for because I need to use the same REPL for the two sections, so I'm going to make another subfolder calling section 3. You don't have to make this folder, just for me. All right, so let's take an example. So every time we'll make a Python, lots of Python scripts. So make a Python script so that name of the Python script that is distinguishable. I'm going to use this name 1pi, 2pi, 3pi. All right, so let's work with the image first. I uploaded an image, the same image in the slide in Notion site. So here's the sample image. So it's only 800 byte size. You might wonder how small that is, but it's less than 1 kilobyte. So you can download your this one. Download. Yeah, just download it here. And then you can upload that file here, upload file, download here, upload here. So it's now uploaded here. So let's move this file into the folder, just drag and drop. Let's change the name, sample.png. Okay. So now 1.py and sample.png are in the same folder. So let's change the write the 1.png, port numpy as np, plot lib. So you might just want to copy paste these 2 lines every time, because we're going to use this every day, I mean, almost every Python code. So first task is to read this image file and then see the information of this image file. Right, so I said that imread is a function that reads the image file information. It's in the pyplot package. So when you do this, you're trying to read the sample PNG, which has happened to be in the same folder, and read the image information and store it in the variable called im. You can change the name of your variable whatever you want. So we want to see the size, what's the type of this image. So first of all, every data has a type. In every programming language, if you want to deal with the data, you need to know what the type of the data is. So let's check out the type. So how do you run this Python code? As I always say, don't press this button. This button is for, main.py in the root folder. Don't use this button. So open up the shell. So the way you can open up the shell is that, okay, so if you don't have this, then you can either use split pane or make a new tab here. So I'm going to split panel. So I'm going to put it on the bottom. And then here in the new tab page, you can have lots of options. So if you go down, down, down here, there's a menu called shell. So shell is a terminal. Press shell. Now you have this prompt. So go to the folder. Our current folder is 9.4, and so this is for my own purpose. I'm in the section 3. So now you can see that my folder is changed. At first, this is my root folder. And then I changed to my subfolder where 1.py is in. So now in this folder, then I can use Python 3, 1.py here. So if it's the first time opening or doing this, you might encounter some error message because this is not installed automatically. So what you have to do is pip install matplotlib. Then it installs this package. It downloads the matplotlib library from somewhere in the web, then download it on to your system. Okay, so the reason why I'm using this, the Replit, is so that I can help you whenever you need help. So on the fly. So as I said, if you are in trouble, don't know what to do, raise your hand. So I'm gonna do this for first few weeks so that all of you are comfortable using Python. So I know that you're learning the Python anyway, but not as much as you should. So you can use this class as some sort of a session that you can work on the Python programming. So raise your hand if you need trouble, if you need help. Yes, what's your name? 김다현? 나연? 나아영. Okay. Is this one? Okay. Okay, so you don't have to put this folder here. So this is for me because I'm using the sections 3 and 5. So, well, nothing wrong in here. So, what's the problem? Okay, so let's try to run this. So the reason I'm showing the students page is that you might have similar problems. So so that you can fix by yourself. So I'm going to open up new panel, shell here, and go to the folder. CD 9. Okay, I'm going to run the Python code 1.py. Okay, this works. So I'm going to keep saying this every time, but you have to go to that folder in order to run the Python script in that folder. Well, you can do it on the root folder if you specify all the detailed location of that file, but it's too much. So anyone else having trouble? Or, well, let's do one more thing. So we now know what's the type. So here again, so let me show you the result here again. Section 3. Oh, here. So Python 3 1.py. So it says, so it's the result of this print command. It says the type of im variable is numpy dot and the array. So numpy dot means it's the whatever type defined in the numpy package, and it's the ND array type. So ND array is actually the class defined in the numpy. So now we know what the type is. So let's try to see the size of this data. So ND array is basically n-dimensional array. So it could be one-dimensional array, meaning the vector, or two-dimensional array, meaning a matrix, or three-dimensional or four-dimensional array, whatever that is. So what's the shape? Let's see, let's print out the shape. So this ND array has a field called shape, and it gives you the shape of your n-dimensional array. So if you run this again, changing this print part, it says the shape is 18, 18,4. What does that mean? So first of all, the first two 18s must represent the number of row and column because we used the 18 by 18 pixel image. And what is the last 4? That's the vector representing the color. So let's try to look up, let's see, 0, 0. So the first index is 0 and second index 0. I want to see what's in the first row, first column. Okay. So it says it's 4 number, list of 4 number, 0, 0, 0, 0. So now that should represent the color, but we talked about the color is represented by 3 values for red, green, and blue. There are 4 here. What's the last value represent? So first 0 is the strength of red, green, and blue, and the last one is the opacity called alpha. So alpha 0 means that it's opaque. So, it's transparent, 100% transparent. If you don't want it, if you want 100% solid, then it must be 1. So here, it means basically it has no color, the white, and it has no, it has 100% opacity. All right, so let's draw it. So we now know that this im contains all the information about the image file. Let's try to draw in our Python window or Python style. So imShow draws an image based on the information stored in the variable. So I'm going to store this image. So if you are working in a local machine, you can finish the line here because it will pop you up the window showing the image information. But here we are using the web browser, so we need to save this information into a different file, different image file. So I'm going to use savefig function to save the image information in different file. So this means that it stores whatever shown in the image, shown in the window into a 1.png file. So let's run this. So the output is automatically open, but we're not using output window. So now once I run this script, you can see that there are one more file created, says 1.png, because I specify the name of the file that I'm going to create as 1.png. So if you click this 1.png, you can see the information here. So let me put it in this way. So I'm going to close this one, make it this one. Yeah, now you can see that the actual PNG image, but this is not the actual PNG image. It's a PNG image with some other information where each pixels are, where the pixels are. So you can see that the vertical axis 0 to 18 and the horizontal index 0 to 18, but somehow it doesn't show you the integer, but it kind of gives you the axis label automatically generated. And it's upright position because it's not following the conventional rule of y-axis. It's not increasing to the upward. It's decreasing. Okay, so it's only it's just showing you that the image in a correct position, correct direction, so that you know what the images are. Okay, let's try to rotate. Okay, or before you rotate, let's try to do the similar output, make a similar output without using imShow here. Okay, without using imShow. So what we're going to do is a scatter plot. So I'm going to use PRT scatter. So scatter only draws the point. For example, if I want to draw the first point, let's see. Oh, sorry. So if I say 0, 0, let's see. Size equals to, let's say, 30. I should test out before I see how it looks. So I'm going to save this. Oh, by the way, so I shouldn't erase this. Let me not erase this code. Okay, so leave this as it is. Let me make another Python file. So I'm going to use this one. Okay. I'm not going to read this one. I just want to test out what the scatter function does. So I'm going to plot some point. Let's say point first. Point size 10. Maybe size is not here. Anyway, so and then let's save the image in 2.png. Okay. Oh, I think the size. What was this? Marker size? So there's the option attributes. I think it's correct. Size, scatter by multiple values. Oh, it's because this. Okay, so marker. Okay, yes. S is okay. S is 10. S means the size. I just need to specify what field is for this dot. So I specify the shape of a marker as the dot, the circle dot, and the size of the mark to be 10, whatever the 10, whatever the size of the 10 is. So let's run this code. Now you can see there are another file, 2.png created. Let's see how it looks like. Very small, too small. So let me change it to, let's see, 100. So size is now 100. I think it's getting a little bit bigger. Yeah. So it's still small. Well, let's see how about 500. Okay. So you can see that this is just marking the whatever the markers. So if I change this to not dot but the comma, then it draws the square mark like this. Okay. So what I'm going to do is, instead of using imshow, I'm going to use a scatter to plot all the pixel points of the image. Okay. So let's try that. So first of all, I need to read the information of the image because I need to know the color. And what I need to do is scatter only takes either the value of each x and y coordinate or array of x and y coordinate that you want to draw. So it can draw multiple points at the same time if you provide array of x and y coordinate of each point. So what I need to do is I need to find out array of x and y coordinate representing each pixel in the image. So let's take x array, range of array of pixels. So what did I say you about the image here? So there are 18 by 18 pixel. That's how many? More than almost 300, something like that. So it's hard, it's impossible to just write out all the pixel coordinates. So we need to use the iterations. So how are you going to, lay out all the pixel coordinates here? Because I need to lay out these pixel coordinates in one-dimensional array. So let me give you an idea here. I'll give you time to discuss what I explained after I finished. So as I said, you need to input the array of x coordinate of your pixel point. But image is two-dimensional. So let's see, these are the image. So each rectangular box is the pixel. And each pixel has x and y pixel coordinates. So if you separate out x coordinates and y coordinates, so this is 0, 1, 0, 1, and so on. So that's an x coordinate. And about y coordinate. So if you want to use the pixel index as a y coordinate, it should be 0, 1, 0, 1, and so on. Right? Remember the slide. If you open up the slide and then looking at the slide, you can see that the pixel horizontal index is increasing when you go down. Okay? So if you simply use the pixel index as a y coordinate, then the point has a y coordinate in this direction, right? It's increasing in this direction. But it's not the two-dimensional, we cannot use two-dimensional array in the scatter. Maybe you can, but we're not going to use this two-dimensional array as an input for the scatter plot. I need to make it into a one-dimensional array. So in some sense, you're looking at the matrix of x coordinate and matrix of y coordinate. How do we make it into one-dimensional array, one-dimensional vector? So you have to choose your direction, but I'm going to choose my direction to be this direction. Okay? And it's going to be go downward. And if I use this direction, it should be the same for the y coordinates. So I'm moving horizontally and then from top row to bottom row and see all the x and y coordinates. So how does x coordinate look like if I do this? If I read off x coordinate in this horizontal direction from top to bottom, it's going to start with 0, 1, and what's the last value? I'm looking at 18 by 18 pixels, so it's going to be 17. And then I move into the second row and start from beginning, 0, 1, and 17. And how many times should I repeat this? 18 times, right? So it's 18 times somewhere else. And how about y? I have 0, how many zeros? 18 zeros in the first row, and second row I have 18 ones, and the last one I have 18 17s. So that's going to be my coordinate, x and y coordinate in one dimension. So I'm going to use this as my input. So x is going to be I for I in range. So let me first height and width and height and width of the shape. So now height and h and width will have a value of the number of height and number of width of this image. So first of all, I'm going to increase my index from 0 to 17 on the horizontal direction. So there are w many number of pixels horizontally, so I need to do this. And then, so this whole iteration gives you 0 to 17. Okay, this whole iteration gives you the list of 0 to 17. But then I need to iterate this again 18 times, right? So this way. So one thing good about Python is that you're really easy to write iteration, but also it's sometimes confusing. So what I'm doing here, let me say it again. I'm doing double iteration. So one iteration, there are nested iteration. So the outermost iteration is this one, the last one. So I'm iterating h times. So actually here h and w are both 18, so you can replace it by 18. But I'm using this variable so that you can change your PNG file later, and it works the same way again. So I'm iterating h times this thing inside. So what is this inside doing? It's also iteration. It's listing I from 0 to w minus 1. Here, the Python range w gives you the list of number from 0 to w minus 1. For example, if you take the range of 18, then it gives you the list of 0 to 17. So that's x. I want to make it into numpy array, so I'm going to numpy array, make it into numpy array. Maybe, yeah, let's do it this way. So, and then let's do the same way, a similar way for y variable. So as I said, we're going horizontally, but in y coordinate, the same number repeats 18 times, and then number increases. So here you can do this. What this underscore means is that I'm not taking any value in the list here. From the range W, I'm not taking any value. It only comes from I, where I is in the range of H. Okay, so this is the outermost iteration. So I'm taking I from range from 0 to H minus 1, and then I'm just repeating W times putting I. Okay, so let's put this here. Oh, by the way, so now I have x and y coordinate in one-dimensional array. What I need to do is I need to put the color information, or I'll get just this. Let me just, let's see how it looks like. I think 500 is quite big, so I think it should be smaller than this. Yeah, something like this. So if I don't specify color, it automatically uses the default color, like a bluish color like this, and then it just produces lots of marks. It's the same color. It's not a picture, right? So I need to use the color information. Scatter also takes the range list of color as the information about coloring. So let's do this. Color is numpy array of it doesn't have to be numpy array, but so it doesn't have to be numpy array. It's a list of just a list of the color information for here the W and H. So I'm just following the same rule here. So I'm using going horizontally first and then vertically. So going horizontally first and then vertically. But if you're looking at the meaning of horizontal index and vertical index, vertical index is the row, okay? Horizontal index is the column index. So when you're trying to get the information about the color in the row column index, the horizontal index, I, should be the column index here, and vertical index must be the row index here. So that's how you should put here. Image ji, not ij, okay? And then for technical reason, we cannot use simply the numpy array for the color information. I need to convert it into a list. Not the list, sorry, it's not a list, tuple. So that's just a technical reason. And I'm going to specify colors to be C. Again, if you have trouble, let me know anytime. I don't want you to frustrate it. Oh, by the way, sorry, not this one. Sometimes auto-compilation, it's sometimes good, sometimes bad because of this. Color, maybe color. Okay, yeah, I got color. Yeah, so it's not colors S, it's color, just color. Okay. Okay, now we have a similar picture as we got from mshow function. Okay. It's a little bit fatter than normal. It's because, you know, these are at the same range of x and y coordinate, but, you know, it's a little bit stretched. I don't know why Python is doing that. I think Python likes this 4 to 3 or this kind of ratio, aspect ratio. So if you want the same ratio, then you can put PLT axis equal. Just make the axis scale the same for both of x and y. So then now you get the actual picture here. So you can see that this is, upside down. Why it's upside down? Because I used the y coordinate as the pixel coordinate. As I said, the pixel coordinate is inverse y coordinate. So instead of using I, if I use 817 minus I, then I get the upright position. Mario, the original Mario here. Okay? Okay, now let's think. So, any questions? Yes. It's not rectangular. Let's see. 이환이? Let's see. I'm going to erase, go this. Okay, so let me look up the file first. So 2.png. Okay, and then let's run this code first. Okay, I guess you get the picture here. Yeah. Okay, so your question is, I don't get the square marker because you put the marker shape as dot. So there are options. You have to look up the documentation, see what other options are. So if you put the comma instead of dot, then you get a square. Where is it? Where is the comma here? So if you put the comma, now you get the square. Okay. It's not important. It's just the square so that I can give you the feeling of what the pixel image looks like. Anyone else? Okay, how about, so I told you about how to rotate a vector. Okay, how about we discuss, I'll just challenge you by giving you the chance that you can you can do it by yourself. So also you have a team. So let's try to make another Python file. Similar here. So I say almost similar here. So I'm going to copy paste almost everything. Where is my pi? Okay, 3pi. So I'm copy paste here. So if you're just doing this, we get the same picture. Now I change it to 3.png. But I need to do something here. I want to do something. So do something. You don't have to write this comment. So comment is something that you want to deliver some information to the reader. Do something on, so with x and y to get rotation. So do something here. Do something here before you go through this. Do something on here. So what should you do? So I'll let you think about, or maybe you can just talk to your friends next to you right now. What you should do in order to rotate the picture. Like for example, let me show you the picture. in the slide, this one. Yeah. Like this one. If you want to rotate Mario, what should you do in between this X and Y and scatter plot? let me show you again. The person in the first column is the leader. Here, the person in the first column, the person is the leader. So you have to, I'm going to, this person has to gather people around and how figure out how to figure out the best way. I'm going to ask them how they're doing. Okay, so any group figured out how to rotate? Is there any group figured out? We can see their replit, see how your group did. Raise your hand if your group figured out how to rotate it. Okay, so group 5. So can I see your replit? 김형준, 현고. 현동. Okay. Okay, so let's see together. So here is it 3 dot pi or is it 4 dot pi? 3 dot pi? Okay. So all right, so here is the inserted line. So what he did is define the theta pi over 4. So he wants to rotate 45 degree, and then define another lumpy array. So you can see it's just a very nice. By the way, I actually saw he got the right image. So anyway, so what he did is making a double list into a matrix, because you can see that this is form of 2 by 2 matrix. You can see it like this. So the first list is the first row, and the second list is the second row, and each row contains the component that goes to the rotational matrix. So if you take this double list, it's just a list, but if you put it into NumPy array or convert it into NumPy array type, it becomes a matrix. So what are you going to do is using this the rotation matrix multiplied on every 2 by 1 matrix representing a point, right? But instead of doing for each point, he did like this. So he first concatenated 2 row vectors, x and y, and make it into another NumPy array, and then made matrix multiplication, rotation times xy. So it's a very nice. I'll give a little bit more explanation to this because some people might not understand why we are doing this. So we have array of x to be the list of x coordinates. So let's see, it's x0, x1, and so on, right? It goes somewhere else. And y is array of y coordinate, y1, and so on. So here you can imagine that each, let's say, each column here is the zeros point, coordinate of a 0 point, and first, and so on. So if you concatenate these two vectors row-wise, then you get a list of x and y coordinates as a row vector, a column vector, right? So from here, I'm going to make xy to be a 2 by 2 matrix, x0, y0, x1, y1, and so on. So what did I say when you talk about the matrix? You can always consider it as a matrix of vectors, right? So you can consider this as v0, v1, and so on, where each v is the column vector representing the ith point. So it's a zeros vector representing zeros point. Okay, and so on, v1, 2, and so on. I think, is it 324? 18th square is a 324, right? So you have a rotational matrix, the R theta, and what if I multiply it to x and y? So x and y is not a good notation, mathematical notation. So let me write it as, let's say, big P here. So big P. So this is R theta 2 by 2 matrix multiplied on V0, V1, and so on. What happens is you can simply consider each Vi as if it's just the number that can be multiplied onto the R theta matrix. So it's R theta V0, R theta V1, and so on. So what is this vector, first one? So it's a 2 by 1 matrix. It's the zeros point rotated by R theta matrix, and so on for the next 2 by 1 matrix. Okay, so if you get all the ith column, then you get ith point rotated by R theta matrix. That's what this code is doing. This code is doing. So how do you get? So after doing all this, you still get the first row representing the x coordinate, but now it's the x coordinates of rotated points. And the second row is the y coordinate of the rotated points. So how do you get the first row? As I said, these two-dimensional arrays are entry of two-dimensional arrays are accessed by each specifying the index of the first index and second dimensional index. The first dimension represents the row. So if you do this, then you get all the zeros row in this xy variable. And here the first row and the index 1 row and so on. So yeah, I'm pretty sure you get this. Yeah. So you have rotated picture. So it's because the reason why it's a little bit squeezed is because not scaled the same way x and y. So if you put the option that makes the x and y scale the same, then you get the 45-degree rotated image. All right, so very good. How about now we actually do the captcha here. So let's make So let's try to generalize this idea. So I want to, let's see, rotate the letter 1. Okay, so number 1. So what should I do to make image of number 1 rotated? So first of all, I need to create image of 1, right? Either I get the image of 1 from other source, or I have to create one by myself. So let's create the image of 1. So import numpy as np, import also matplotlib, pyplot, splt. So first of all, I need to draw the text. There is a function called text that draws you the text string in the xy coordinate. So here I'm going to draw 1 and then save it to here's 4.png and see what happens here. Where is it? So maybe it's too small. It's actually here, and you can't see because it's still too small. So let me change the font size. So font size is 20. I think it should be a lot bigger than 20, but let me make it bigger a little bit so that you can see now 1 appears on the bottom corner here. And okay, so we don't want so this entire thing is an image as a whole image. I only want to separate the image 1, okay, like a part 1, right? So I need to get rid of this axis. So get rid of this axis information, axis off. So let's draw it again. I didn't close this parenthesis. So now axes are gone, but 1 is, actually in the 0, 0 position, but since the range of x and y's are from 0 to somewhere far away from 0, so it's not in the center. I need to make it into a center. So I need to specify the range xlim to be, let's say, minus 0.5. So I will adjust this later according to the picture size. So now it's in the center. It's a little bit off. It's because there's another option when you draw the text that if you want your text to be aligned in certain direction, then you need to put some option value here. So instead of so I want the horizontal alignment to be centered and vertical alignment to be centered too. So center. Okay. So there is an option called a field called font size HAVA. These are all option field for the text function. I put a value for each options like this. And then, yeah, you can see the alignment, it's changed, and now it's actually in the center position. And let's make it a little bit bigger, not a lot bigger actually. So how about 80? So it's now quite big, but it's still, there are so many empty spaces around the letter 1. So I want to get rid of these excess spaces, margins. And I'm going, so this is a, oh, what's it? Interesting. So this is another option that actually, this is something that I looked up in the website and then nice to me. You can get rid of all the margins of the image by putting this B box inches. So make it tight. So you get rid of all the margins. Yeah, so you can see actually getting bigger. So if you draw your axis, then you can see that it's tight to the axis information, but we took off the axis information. And okay, so there are several options that I can also configure here. So maybe how about I want to make axis to be scaled equally, x and y. And how about, okay, so I want to, let's see, make it a little bit tighter to the image, to the letter. So it can be either increasing the font size, or I can limit the range of x and y to be lesser than 0.5. Maybe not. Doesn't make change. So maybe I should increase the font size. How about 200? Let's see. Yeah, it's a bit better. It's better. And okay, so how about, well, if it's okay for you, then it's fine. Yeah, you can work with this. So we can get rid of all the white images later. So let's work with this. So you saved your image of 1 in the file name 4.png. So here, let's work with this. So now I'm going to open up another file, 5.py. So I'm going to leave it open so that you can see how 4.png looks like this one. So I'm going to read the information that I just created of the image of 1. So instead of sample PNG, 4.png, what I want is the image size, shape. I want the width and height of this pixel image. So let's run this code. So it says, oh, it's quite big, 389 by 515. So if you multiply these two numbers, that's a really big. You don't want to scatter plot all of these points, right? So what I want to do is retrieve just the part where it indicates the number. So you can see, you can remember that number is the color black. I just need a pixel whose color is black, okay? So here, height and width. Let me just take the shape, entire shape first. And then, well, I have to do the same thing for x and y. There's no way other than doing this. But be careful about this x and y coordinate. So doing that same thing, but here in this case, y coordinate is changing from height to 0. Okay, so height is different from the previous height, the sample PNG height. So this height is now 389. And now color information the same, H here. But what we're going to do is, I'm not going to use the entire array here because it's too big. It's not efficient. So I'm going to separate out the color, which are just black. So the K is the list of I for I in range of length C. So it's better to make it into bigger shape here. So K represents the index of the array C, where the entry, this entry that represents color, actually represent the black color. So K stands for key, and it's meaning the black. For if this is, oh, by the way, so if this plus is, so if it's black, then yeah, so it must be bigger than 0. Let me check. So in the beginning, before we sort out the colors, there's, let's see, where is too big? Yeah, still too big. Before we sort out the color, there are 200,000 points. But after we sort out, there's still 190,000. So that means I didn't sort out well. So if that is not bigger than 0, maybe, let's see. So I want the black color. So how about doing this? Why just so many? So how, yeah, well, let me check again. So how I sorted out the black colors. Oh, I multiplied. So I want to multiply these numbers. So these numbers are RGB, the red, blue, red, green, and blue. I want this to be less than 1. Okay, so now it's way smaller than 200,000. So now you only have 9,000 points that actually has a black color. Okay. So I just need these indices. So I'm going to collect just these. Maybe abbreviate a little bit more. Xn, YK, and CK. Okay. Why is it problem here? Okay, whatever. So I'm going to use a scatter. Let's see if it works well. So here, marker is point, and I don't want too big of size. Just need this. If it's equal, let's save it to 5.png. And let's see if it works. Not sure why is it asking this one. So K. Oh, I see. Okay, so C is not numpy array. That's why. So C, I want this to be CI for I in K. So I just want the index in K. Yeah, that's best I can do here. Let me show you the result. So I can create a 5.png. Okay. This is the image created by scatterplot. So what I did is I first created the image of text, and then I read the text and then convert it into XY coordinate and then scatter plot. Why do I do this? Because I want to rotate. I want to do something on this image. So in order to do something on image, I need to convert the information of image pixel image information into XY coordinate information. What I just did in the 4.py is that I create an image of text. So there are underlying function that makes into an image file, but that doesn't rotate or whatever manipulation I want to do. So that's why I need to read again into an image file. So now we can do the manipulation. So let's see, I want to rotate by theta amount. Let's say I want to rotate by 1, so 1 radian, okay? So then there's another way you can do this. instead of using matrix multiplication, you can, let's see, x and y equals to this. So instead of defining matrix, you can directly apply the formula after you're taking a matrix multiplication or rotation matrix. So that's the formula. So this x and y should represent the x prime and y prime I just explained before, but I'm just replacing into x and y again. I don't change the information of C because I don't want to change the color. But if I do, then you see a rotated image. So I want to, if you want to get rid of the axis information, then take off. Then you get rotated image. So how do you dilate? Now, how do you stretch? Well, let's do the same way we did before. So x and y will be stretched by some amount. Let's say I'm going to stretch x by 2, and 2 is too big, maybe 0.5. And I want to, let's see, decrease or squeeze the y direction. So I'm going to squeeze by 0.8, and then rotate. That gives me this, distorted image. So what should I do next? I just did for one image. I need to do it for several images and several characters, right? So, okay, so assuming that we did for a different number, but I'm going to use the same number 1, assuming that I got this for another number. If I have 2 numbers that I can manipulate, I want to put it into the same window, same image, right? So I did it for 1. If I did it for another number, but let's do it with number 1 again, I want to put this in somewhere near 1, but not random position, but somewhere a little bit to the right of number 1, okay? So how would you do it if you want to put another number right next to the number 1 here? So we did for one number, do it similar so that you can put another number next to number 1, a little bit overlapping to number 1. So you have to read off the, this axis actually, how much you have to move the numbers here. So because every number you will create and then read off x and coordinate will be centered at the origin. If you want to put another number to next to the previous number, you have to shift the coordinates in certain direction, right? So, okay, so this is your task. This is your task to make the image of 2 letters that are next to each other, but overlap a little bit, overlap each other, okay? So we'll do a little bit of discussion, and then I'm gonna finish by 12 to 20, but I'll still try to answer the question if you have any. Or raise your hand if you didn't followed up to this point, so we can go through together looking at your code. So everyone okay getting this image? If you didn't get this image, do you have a question? Okay, let's see. 장나연, 장하빈. Okay. Okay, so here, so you get 4. I think you didn't get 4 right. Okay, so, all right. I think most of people got this far. So let's do a little bit modification here. So we can turn off the axis first. You don't want to see the axis. It's font size, not font size. So there's a typo here. So and then let's do it here. So 4.pi. So the image here, now it's 1. Okay. So now let's use the 5.pi. Reading 4.png here. I think it's less than 1. And then everything is okay. Let's try out first. Here's a 5.png. Yeah, you got this value. The reason why it's, yeah, it's you used a different value here, so that's why it got a different number, but that's fine. Yeah. Yeah, basically you got the same figure, right? Yeah. Tilted. So you got the basic idea, right? You print out the number as an image, read the image again, and then do something on the image, and do it again for different numbers. But if you do it again at the same position every time, it will overlap at the 0.0 all the time, so that you cannot know in which direction number is progressing. So you have to shift your image of number a little by little, so that you can see which letter or numbers are first to type in and then last to type in, right? That's how that's basically the CAPTCHA. Okay, so let me finish by coloring. So here I use the color. So actually I don't need this information actually, because we're not going to color into black. We're going to make it into random color, right? How do you generate a random color? So you have to import the random package here. You can import anywhere, but it's better to import in at the first, but I'm doing this anyway. So C is random. I think it's a normal. Yeah, normal 3. And then it's a tuple. Yeah. Is it? No, I forgot the type of this normal. So I think it's ND array. I think it's better to just not using normal, just rand tuple. Okay. So now I just added 2 lines here. What happened is, before then I used the color, a black color, because it was the original color. But I changed the color to the RGB color, whose values are randomly chosen. So let me run this again. So you can see every time I run this code, the color changes a little bit, not a little bit, quite differently. Okay. If you use this color all the time, then this will not give you the nice overlapping picture, because it doesn't have opacity. So I need to give some opacity to here. I think 0.5 is too big. So let's see. If I put alpha as 0.3, then it's not literally 30%, but I will just say it's 30%. So it's basically something like the color are seen, only 30% of colors are seen through the color behind. Okay, so 70%. So 70% of the color behind is seen through this color. So it's like 30% of light is passing through this. So you can see that the colors are a little bit dimmer than before, like this one. So you can see that now if you do this for different numbers and different positions, you can see the nice overlapping. So try to work on your own first, and then you can read the script that I uploaded in the slide that is actually about making a class. So Python, basically, if you want to do it properly, you need to understand how to write the class in the Python. So I done this way, done that way. But if you don't understand how basically you do make a captcha image without class, then you will not understand what's going on in the script that I upload in the slide. So make sure you understand. Also, make sure you do my assignment. It's not assignment that you have to hand it in, but just to do it on your own. The assignment is make 2 or more letters in one figure that are overlapping each other. Okay. All right, so let's call it here. See you on Friday. If you have any question, let me know. And also, if anyone wants to talk about your registration, talk to me after class.